Hi, in this video I want to show you how to do chi-square distribution hypothesis test, in particular the goodness of fit type of test. I'm going to be looking at problem 16 on page 561. And in goodness of fit test, we have a set of data and we expect that data to fit a certain distribution, but our sample data suggests otherwise. Now in this problem, a researcher wants to determine if bicycle deaths are uniformly distributed over the days of the week. And she selects 200 deaths that involve a bicycle and records the day of the week that the deaths occurred on. And it suggests, with the range of data from the lowest value being 16 to the highest value being 41, that maybe the deaths don't occur uniformly with respect to the day of the week, that maybe the deaths occur more frequently on some days than on other days. So that's the setup for doing this particular type of hypothesis test. Your categories might be days of the week, they might be months of the year, they might be regions of the country, something like that, where we have some expected distribution. And in this case, our null hypothesis is that the deaths occur uniformly, that it doesn't matter what day of the week, they're going to be about the same every day. Now on the TI-84 calculator, you actually have a built-in function for doing these tests. Let me show you that really quickly. I'm going to go to the Stat menu and then over to Tests submenu. And then if I scroll or arrow up from the bottom, you can see here item D is chi-squared GOF test, goodness of fit test. But in this video, I'm not going to use this function. Well, I'll give you an example of using this at the end, but I want to focus on the situation where you have an 83 or 83 plus and you want to do this particular test by hand. Now if you're doing this problem with pencil and paper, there's a lot of computation involved, and I want to show you how you can use your calculator to do this more quickly, more easily, more accurately. And we do that using lists. So I'm going to go into the list window, and you can see I've already entered over here in the list view in L1 the observed values. These were the 200 data points sorted by day of the week, and that's the data I've put into L1. So those are my O values or my observed values. What I want to put into L2 now are my expected values, and these are the values I would expect to have if the deaths occurred uniformly. So for example, for Sunday I would expect it to be 200 divided by 7, about 28.6 deaths each day. So that value is going to be the same for Monday, Tuesday, and so on. So what I'm going to do is enter that same value, 200 divided by 7, 7 times. What I wanted to point out in doing this is that you don't have to compute 200 divided by 7 and then enter that value. You can enter the expression directly as a list item, and your calculator will do the computation and store the result for you, which is a better way to do it because it stores a more precise value than your recording 28.57 or 28.6 and storing that value instead. So I have in list L1 my observed values from the table, and I have in list L2 my expected values, where the expected distribution is that the deaths occur with equal frequency. Now what I want to do is to compute the O minus E squared divided by E value for each set of data, for each category. And I can do that using lists in this way. I'm going to enter that expression using parentheses second L1, which are my O values, minus second L2, which are my E values. I'm going to take that difference and I'm going to square it, and then I'm going to divide by the E values. Now when I do it this way, it's going to take each pair of data values and do this particular computation for them. So what's going to happen is I'll have 7 results for each, one result for each pair of values. And so I need to take those 7 results and I need to store them into a third list. So I'm going to use L3. So that was the store key and then second L3. And now when I press enter, it does the computation for each pair of O and E values and puts the result into list L3. Now the second step for computing test statistic is to sum up all of these values, and I can do that in one step. If I go into the list menu, which is the shift function over the stat key, So I'm in the list menu. I want to go over to the Math submenu, And you can see the fifth item down is a summing function, number 5. So I want to sum list L3. And now when I press enter and it sums those results, it gives me the test statistic for this test, 19.03. Now the second step that you're going to want to do is to compute a p-value based on that result. And if I go into the distribution menu and I choose, in this menu for the 84s it would be item number 8, and in the 83s I believe it's item number 7, chi-squared CDF is the function I want, and this works a lot like TCDF, where you, well, with chi-squared distribution tests, these are always right tail tests, so you're going to give it your test statistic, so I'm going to give it the previous result stored in ANS, comma, a value way out in the right tail, like 999, and then the degrees of freedom. In this case there are 7 categories, so that means 6 degrees of freedom. Okay, so those are the bounds, lower and upper bounds, and then the degrees of freedom for a chi-squared distribution, and it returns the probability, or p-value, 0.0041. At this point you can compare this to your alpha value given in the question and come up with a decision. And since p is much less than alpha, that means we reject the null hypothesis. We reject the idea that the bicycle fatalities occur with equal frequency with respect to day of the week. Okay, so that's basically how you can do a goodness of fit test on your calculator using lists. And what I hope you realize is this is a better way to do it than to work out the computation for each category by hand and sum by hand and so on. Always better to put the data into lists and handle the arithmetic in terms of lists. If you're using an 84, let me show you quickly how you would do this test. And if I choose chi-squared GOF, what you're going to see is it's going to prompt you for the observed values in a list, which is how we have it at list L1, and the expected values also in a list, L2, degrees of freedom, which we have decided was 6, and then we calculate, and it returns the same values we just got doing it by hand, your test statistic and your p-value. Okay, so that's how you can do it if you have an 84. But as I said, if you have an 83, it's just a few more steps handling the data in lists and doing the math that way. So the next video I'm going to talk about will cover another type of hypothesis test for chi-square distributions, and that's tests of independence or homogeneity. And in that situation, both the 83 calculators and the 84 calculators have a built-in function to do those tests, the same function, and that requires the data to be put into matrices. So I'm going to go through that procedure in that video. So anyway, this concludes showing you how to do the goodness of fit test using your calculator.